Stoichiometry, concentration of solutions. Hi there class, this is the last topic for the chapter of moles and calculations. As usual, before we begin, please ensure you have these relevant materials. They are the notes chapter 8C on stoichiometry, calculator and periodic table. Once done, let's go. As usual, the top will show the page number and subtopic. The underlined words should be filled in your notes. If there are any highlighted words, you may choose to highlight them. And if there are scribbles or red words, add them on to your notes. Alright, so turn to page 6 of your notes. We shall now talk about the concentration of solutions. So a quick recap. We'll be talking a lot about dm cube, and 1 dm cube is 1000 cm cube. So, what is concentration? The concentration of a solution is given by the amount of solute, either in grams or mole, dissolved in a unit volume, usually in dm cube, of a solvent. And the solvent is usually water. Okay, so I repeat that again. The concentration of a solution is given by the amount of solute dissolved in a unit volume of a solvent. It can be expressed in two units, either gram per dm cube or mole per dm cube. For example, 50 gram per dm cube of sodium chloride solution means I have 50 gram of sodium chloride dissolved per 1 dm cube of water. So let's say I have 50 gram of sodium chloride here, and I have 1 dm cube of water. So 50 gram per dm cube would be this amount of sodium chloride being dissolved in the 1 dm cube of water. Now, if I have 4 dm cube of this solution, okay, how many grams of sodium chloride will I have altogether? So once again, this solution concentration has 50 grams per 1 dm cube. So if I have 4 dm cube of this solution, I will actually have 200 grams of sodium chloride. Okay, another example. 3 mole per dm cube of sodium chloride solution means I have 3 moles of sodium chloride dissolved per 1 dm cube of water. Same thing, we have 3 mole of sodium chloride in 1 dm cube of water, and I dissolve it. So if I have 5 dm cube of this solution, how much moles of sodium chloride do I have altogether? Right, so since each of them has 3 moles of sodium chloride dissolved, if I have 5 dm cube, I will get 15 moles of sodium chloride. We can calculate concentration by two formulas. Okay, for the mole per dm cube concentration, okay, it is the number of moles of solute over the volume of solution in dm cube. Right, you can refer to the formula triangle. For me personally, okay, I prefer to use the equation form because it seems clearer to me. We can also calculate concentration if it's in gram per dm cube the same way. Okay, but this time we use mass of solute in grams over the volume of the solution in dm cube. Okay, so the first one was mole per dm cube, so there is mole over dm cube. And now this is the gram per dm cube, so it's the mass in grams over dm cube. Sidetrack a bit. Let's take a closer look at what concentration means. Okay, let's say I have 1 mole of X dissolved in 1 dm cube of water. So the concentration will be 1 mole divided by 1 dm cube. So that will be 1 mole per dm cube of X. Then I have a second solution. This time is a bit darker in color. Same volume of 1 dm cube, but I dissolve 2 moles of X. So what will be the concentration? will be 2 moles divided by 1 dm cube. So I have 2 moles per dm cube of X. And lastly, I have an even darker solution. Same volume of water, but I dissolve 3 moles of X. And that will be 3 moles per dm cube. Okay, so you can actually imagine concentration as adding food coloring. And the more you add, the higher the concentration, the darker the color would be. Let's take a closer look at one of them. 2 moles of X dissolve in 1 dm cube. So I have 2 moles per dm cube of X. Okay, now I have the same concentration of a solution, 2 moles per dm cube, but it is actually 3 dm cube of the solution. Now the question is, how many moles of X must I dissolve so that I get the same amount of concentration, 2 moles per dm cube? So how much X do I need to achieve the same concentration of 2 moles per dm cube? Okay, think about it. Alright, and that is 6 moles. Okay, because to get the same concentration, okay, when I ask number of moles, I will need to multiply the concentration by the volume of the solution. So in this case, the number of moles would be concentration times volume, which is 2 moles per dm cube multiplied by 3 dm cube, and I get 6 moles. Okay, one more thing. If I have 1 mole of X dissolved in 1 dm cube of water, I will get 1 mole per dm cube of X. Now I divide this solution into 2 equal parts. The question is, will the concentration be halved? Okay, I'll give you some time to think about it. Okay, the answer is no. The concentration remains the same. Okay, why is that so? Right, when I divide it in half, okay, there will also be 0.5 moles of X dissolved in each of them. Okay, and the volume of water also will be halved, 0.5 dm cube in each of them. So the concentration in mole per dm cube would be the moles of the solute over the volume of the solution. So in this case, it will be 0.5 over 0.5, and I also get 1 mole per dm cube. Okay. Another way to think about it is the color will remain the same, not less. So if you have, like example, a mixture of water and rose syrup, okay, you mix them up, okay, then you in one jug and you separate into different cups. Okay, all of them will have the same concentration, okay, just different volumes. Okay, so the color remains the same, not less, any less faint. So please note, dividing solutions into different parts will not change the concentration. Alright, one more thing to take note. If I have the same amount of X 1 mole dissolved in 1 dm cube of solution, and I get 1 mole per dm cube of X, what can I do to halve the original concentration? Okay, since dividing the solution into 2 does not make it half the concentration, so how can I make a solution with half the concentration? Think about it. Okay, right, one way would be to add more water so that it is twice the volume. So if I add more water, okay, you can imagine the color becomes less concentrated. Okay, I have the same mole of X dissolved, but now I have 2 dm cube of water. Okay, so when I add water to it, I make it less concentrated. So in this case, it will be moles over volume of 1 mole divided by 2 dm cube, and I get 0.5 moles per dm cube. Okay, another way to think about it is how to make the color fainter. So example, you have your syrup drink and it is too sweet. Okay, how do you reduce the concentration? Okay, you add more water and the color will actually be fainter. Okay, so on to page 7, example 1. Calculate the number of moles of sodium hydroxide contained in 150 cm3 of 2.0 mole per dm cube solution of sodium hydroxide. Okay, when I get this kind of questions, I always like to highlight what each quantity is representing. So we have 150 cm3, which is volume, and we have the concentration, okay, 2.0 mole per dm cube. Okay, and the question wants us to calculate the number of moles. So using the formula triangle, to calculate the number of moles would be the concentration multiplied by the volume of the solution. But before that, okay, since the volume is in cm cube, I need to convert it to dm cube. So 150 cm cube, if you divide by 1000, you get 0.15 dm cube. So the number of moles would be the concentration multiplied by the volume, which is 2.0 multiplied by 0.15, and I'll get 0.3 moles. Okay, you may pause the video here to write down the workings. Next, example 2. Calculate the concentration of hydrochloric acid solution in moles per dm cube if 400 cm3 of the solution contains 0.25 moles of HCl. So once again, I like to highlight what is given in the question. We have the volume and the number of moles. So using the formula triangle, to find the concentration would be the number of moles over the volume of solution. And once again, it's given in cm cube. So we need to convert it to 0.4 dm cube first. And the concentration would be number of moles of solute over the volume of the solution in dm cube. In this case, it will be 0.25 moles over 0.4 dm cube. And I get 0.625 moles per dm cube. Take your time to write the workings. Example 3. Calculate the mass in grams of KOH in the beaker if 300 cm3 of 56 gram per dm cube KOH is poured into the beaker. Once again, I highlight what is given. We have the volume and we have the concentration, but this time it's in grams per dm cube. So to calculate the mass, okay, I will multiply the concentration by the volume. And once again, it is given in cm cube. So I convert first to dm cube. So the mass in grams would be the concentration multiplied by the volume, which is 56 multiplied by 0.3, and I get 16.8 grams. Alright, moving on. Example 4. It is found that 24.5 grams of H2SO4 is contained in 750 cm3 of H2SO4 solution. So find the concentration in grams per dm cube. So this is simple. Let's highlight again the mass and the volume. So to find the concentration, it will be mass over volume. And once again, this is given in cm cube. So I need to convert to dm cube. So and the concentration will be the mass over volume, 24.5 divided by 0.75. And I'll get 32.7 grams per dm cube. Okay, after rounding off to 3 significant figures. Okay, part B. Okay, find the concentration in mole per dm cube. Okay, there's an error in your notes. Okay, it repeated grams per dm cube. Okay, but change it to mole per dm cube. Okay, so now I want to find the concentration in moles per dm cube. So to find concentration in moles per dm cube, I will need the number of moles over the volume of solution. But the question only gives me mass and volume of solution. It doesn't give me moles. So think about it. How can I find the number of moles? given these two quantities. Alright, we actually need to use one of the formulas that we have learned before, which is number of moles is mass divided by mR. So in this case, it will be 24.5 over the mR of H2SO4, and I get 0.25 moles. So now I can finally find the concentration in moles per dm cube, which is 0.25 divided by 0.75 dm cube. Okay, I've converted the volume from cm cube to dm cube, and I get 0.333 moles per dm cube, rounded off to 3 significant figures. Okay, moving on. Example 5. Okay, we have a chemical equation. So this is your stoichiometry. If you remember the junction method, where you need to convert everything to moles and compare using the mole ratio. So I have an excess of zinc, which reacts with 0.5 moles per dm cube of hydrochloric acid. 250 cm cube of the acid was used. Calculate the mass of zinc that reacted. So I need to rewrite the equation. Oh yes, before that, okay, I highlight the quantities in the question. So 250 cm cube is the volume of acid, and 0.5 moles per dm cube is the concentration of the hydrochloric acid. So these are our given things. So we rewrite the equation. So we have 0.5 mole per dm cube of hydrochloric acid, and the question asks us to find the mass of zinc that reacted. Okay, so the junction method, we always need to convert whatever physical quantity is given to the number of moles. So for 0.5 mole per dm cube of hydrochloric acid, in this case, how many moles of it is it? Okay, so we have the concentration. From concentration, how do we find moles? Okay, it is by multiplying by the volume of the solution. Okay, it's similar to the examples previously. Okay, but just that now it is in the stoichiometry problem. So I need to multiply by the volume. And what is the volume? Okay, the volume is 0.25 dm cube. Okay, this is because 250 cm cube is 0.25 dm cube. So I multiply that together and I get 0.125 moles. So now that we have the mole of hydrochloric acid, we can find the number of moles for zinc. Okay, using the mole ratio. So what's the mole ratio between zinc and hydrochloric acid? Okay, there's no number in front of zinc, but it's actually 1. So the mole ratio is 1:2. So since 2 units represent 0.125, what is 1 unit for zinc? Okay, you will divide by 2 and we'll get 0.0625. Now, from the number of moles, how do we find mass? Okay, alright, you guys should know this by now. To convert mole to mass, you need to multiply by the mR. Okay, so the mR of zinc is 65. Okay, and I will get 4.0625 grams. Okay, this is an exact value, so I did not round off to 3 significant figures. Okay, once again, I need to point out, technically I should say AR of zinc, since it is one element only and not a compound, but it's okay. So the answer is 4.0625 grams of zinc reacted. Part B. Calculate the volume of hydrogen gas produced. Okay, so same thing, rewrite the equation. Okay, but actually if you have enough space, okay, you can reuse what you have done previously. So we have 0.5 mole per dm cube of hydrochloric acid. Okay, and the question asks us, what is the volume of gas produced? So from part A, we have found out that we have 0.125 moles of hydrochloric acid. So how to find the number of moles of hydrogen? Okay, we will use the mole ratio. So what is the mole ratio? Okay, we have 2:1. So same thing, if I have 2 units of 0.125 moles, so what is 1 unit? And that will be divided by 2, so I get 0.0625 moles. So now, from the number of moles, how do I get the volume of hydrogen? Okay, and now this time, okay, it's not related to concentration. This is for volume of gas. So to get the volume of a gas from the number of moles is to multiply by 24. So 0.0625 moles multiplied by 24 and I get the volume of gas. In this case, 1.5 dm cube. So the volume of hydrogen gas produced will be 1.5 dm cube. Okay, something to take note, okay, because I see this error in many students. Okay, do not confuse the volume of gas formula with the volume and concentration formula. So the volume of gas is for gases, okay, is multiplied by 24, and then the volume and concentration formula is for aqueous solutions, okay, like your, in this case, hydrochloric acid. Okay, last example, example 6. It was found that 3 grams of magnesium oxide required 150 cm3 of of sulfuric acid to react completely. Calculate the mass of magnesium sulfate produced. So once again, okay, we need to rewrite the equation. Okay, this time we are given the mass of magnesium oxide and we are given the volume of sulfuric acid. Okay, but the question wants us to find the mass of magnesium sulfate produced. Okay, so now which one shall I use? Okay, the magnesium oxide or the sulfuric acid? Okay, you actually discover that for sulfuric acid, we are missing one important information to convert it to moles, which is the concentration. Okay, so we will need to use the mass of magnesium oxide. Okay, and personally, if I'm given two different things also, I would prefer to use magnesium oxide because it is given in mass, which is easier to find by dividing by mR to find the number of moles. Okay, concentration is quite a harder concept for me to understand. So for number of moles of magnesium oxide, okay, given the mass, I simply divide by the mR, which is 40, and I get 0.075. So now, how many moles of magnesium sulfate will I produce? Okay, what is the mole ratio? So if you look at the equation, the mole ratio is actually 1:1. So if I use 0.075 moles of magnesium oxide, I will also produce 0.075 moles of magnesium sulfate. And from mole, how do I get mass? So same thing, I multiply by mR, this time the mR of magnesium sulfate, which I'll calculate to be 120. So the mass of magnesium sulfate produced would be 9 grams. So that's the answer for part A. Alright, part B. Now the question wants us to calculate the concentration of sulfuric acid in mole per dm cube. Okay, although volume is given, so they want us to find the concentration. So I have to replace what I need to find now with the question mark mole per dm cube. So same thing, okay, I can find the moles first from magnesium oxide, and we have found it just now, 0.075. Now, using mole ratio, how many moles of sulfuric acid, okay, is reacted? Okay, and the mole ratio is once again 1:1. So I'll also get 0.075 moles of sulfuric acid reacted. So now for number of moles, how do I find concentration? Okay, and that would be dividing by the volume. So mole per dm cube, the working would be mole divided by the volume. So what is the volume of sulfuric acid? It's actually given, which is 0.15 dm cube. Okay, how did I get this value? So same thing, 150 cm cube is equal to 0.15 dm cube. and I will get 0.5 moles per dm cube. And that is the answer. The concentration of sulfuric acid is 0.5 moles per dm cube. Alright, so that's it. Try worksheets 8C on your own. Okay. Alright, it might be a bit difficult, but it's okay. Persevere on. Alright, you will be fine. And that's all we have for mole and calculations topic. So congratulations. Okay, we have finished this whole chapter. Alright, take care.